In this video, we are going to learn how to draw shear force and bending moment diagram for a system like this where you have point load acting at different points. The distances are given. So first of all, let's dive into the calculation. Solution, I will be a little bit fast because the video will be long. Let's determine the force at point A and point B. But before we do that, let me call this point C, point D, point E, and point F. Here is A and B. So let's determine these two forces. You know that summation of the upward force is equal to the sum total of downward force, which is this 20 plus 40 plus 30 plus 100. So let's sum all this. This will give us 190. Let's call this equation 1. That is arrow A plus and arrow B. So for us to get B, let's take moment about A, point A. So if we take moment about point A, let's start with B. So it means that B will out in this direction, while A will out in this direction. So we have minus arrow B multiplied by the length is, summation of all the length is 20. Let's come to this point, plus, because this 100 Newton will out in this direction, plus 100 multiplied by the distance from this point to this point, which is 16, plus 30 multiplied by distance from here to here, which is what? 10, plus 40 multiplied by 6 plus 20 multiplied by 2. So arrow A multiplied by 0. So all this is equals to 0. Here we're going to have minus arrow B multiplied by 20 equals to, let's take all this to this other side. All this is giving me 2180. So therefore arrow B is equals to 2180 divided by 20, which is equals to arrow B now becomes 109 Newton. From equation 1, arrow A is equals to what? 190 minus arrow B is what? 109. So arrow A is equals to 190 minus 109. Okay, is 81 Newton. So we've been able to get the force there. So the shear force there is equals to arrow A also. So the shear force here is 81 Newton. So let's proceed. The shear force at point C, is equals to, as it progresses, subtract the forces. So say 81 minus the next force is 20. So 81 minus 20 will give us what? 61 Newton. That is the shear force at that point. The shear force at point D is equals to, the force is 81 minus 20 minus the next force is 40, which is equals to, this is giving us 21 Newton. The shear force at point E will be 81 minus 20 minus 40 minus 30. This will give us minus 9 Newton. The shear force at point F, let's say at point F, the shear force there will be, let's say 81, let's move 20, 40, 30, and 100. So this will give us minus 10918. Now I've known all the shear force at different points. Let's go into the bending moment calculation. Bending moment calculation. So before we consider the bending moment, which is the first times the perpendicular distance, you have to know that the bending moment at point A is 0 because no distance there. Point A is equal to 0, and the bending moment at point B is also equal to what? 0, 18 meter. So let's move to point C. The bending moment there. Point C, the bending moment there will be what? The force RA multiplied by the distance, which is what? 2. Okay, let's use bracket 2. This will give us 162 18 meter. Let's move bending moment at point D. This will be 81 multiplied by 6 plus, that is the distance from this point to this point, by 6 plus 20 multiplied by 4. This will give us what? 566 18 meter. Bending moment at point E. We have 81 by the total perpendicular distance, which is 10, plus 20 multiplied by the distance from RA to point E, which is what? 8, plus 40 multiplied by the distance, which is 4. This will give us 1130 18 meter. So the bending moment at point F will be this: RA multiplied by the distance from RA to F, which is 16, that is giving us 16, plus 20 multiplied by the distance from 20 to F, which is 14, plus 40 multiplied by the distance from 40 to F, which is 10, plus 30 multiplied by the distance from 30 to F, which is what? 6. So we have this computed at is giving us 2156 18 meter. Now we've been able to get the bending moment values and the shear force value, so we can now draw the diagram. So we can have a line drawn horizontally for the shear force. So let's say the shear force diagram. So anything upward is positive, anything downward is negative. So the shear force at point A, at this point A, what was the shear force value here? Is 81, the next one is 61, so it's dropping. So the highest will be this. This will move, be constant all through to the next point. Here we have 81 Newton. The shear force at this point is dropping towards 61. So it will be constant all through to the next point, which is 61 Newton. The next is what? 21. It drops down to 21. This 21 will be constant all through to the next is what? The next is -9. At this point, E is -9, so come down to negative side of it. Here is 61. this place is 2118, so here is minus 9. So we have minus 918. This minus 9 will move, be constant to the next shear force value. Sorry, to the next shear force value, which is what? Minus 109. This minus 109. This will move to close down. The shear force at this point is 0. At this point, the shear force here is 0 anything. So this is the shear force diagram. Here is positive, here is negative. So let's also draw for the bending moment. Let's take a horizontal. So for the next point, which is point C, what is the bending moment there is 81. I think it's increasing. So let's take this point. So the bending moment there at point C is 162 Newton meter. The bending moment at the next point, point D, is 566, which is this 566 is increasing Newton meter. The bending moment at point E is 1130. It's increasing 1130 Newton meter. Then the bending moment at point F, which is the highest, is this, which is the highest, is 2156 Newton meter. So now we can connect the line from 0 to this point. Please take note to this point, and also from 0 to connect. So please, if this is your first time coming across my video, you have been able to draw the shear force and bending moment diagram, like this video, share and comment. I love you all. God bless you.